Welcome to the Biology 2 experiment, where we're looking at the movement of substances in and out of cells, which is called osmosis. And this is the aim that you're looking at, which you'll have in your booklet: how fast the pH changes when different substances are placed in water. And so what we're going to have is a variety of chemicals that you need to test. And you're going to start off with a beaker, and this beaker here is green in colour, and the only reason why it's green is because I've placed some universal indicator into the water to test its pH. And universal indicator turns green in neutral solutions, right? Now that's a very broad way of measuring pH. We want to be a bit more specific. We want to use a data logger so that we can be more precise with our pH measurements. And so in this investigation, you're going to be using something called a pH probe by Pasco, and it sends its data wirelessly to iPads. So as you can see with this one here, it's a device which it has an electronic component up the top which measures the data and then sends it wirelessly to your iPad. So as you can see here, we've got the data logger here where we've got the electronic component which records the data and sends it wirelessly to your iPad. And then we actually have the pH probe down here. And at the end, if I unscrew this, this is where the measurement happens in solution. And this must remain dry. So that's why we have a container with liquid in there, and we must immerse it back into that once we finish. Just watch out too, you don't want to screw this really tight. It's just firm. We just don't want it to leak. But if you screw it too tight, this plastic lid will crack. So just be very careful of that. This is a very expensive piece of equipment. So this is the pH probe that we're going to be using. So what you're going to do here is place a dialysis tube into your beaker. Now, what's a dialysis tube? Well, it's a tube that tries to copy or replicate the cell membrane of cells. And so here we've got one made up. We've got some string down the bottom, so you will tie it up. Your teacher will help you with this because it's very, very hard to get this to work properly. But we've put some liquid inside here that we're going to be testing. And we want to keep the top open because we want to put the pH probe in the top. Okay? And so this is called dialysis tubing, and it simulates what a cell membrane does. Okay? So that's dialysis tubing. So here's the dialysis tubing here, and what we're going to be doing is you have a beaker with distilled water in it. We saw it before with the green. We have the dialysis tubing in here, and it's in there we're going to be placing different substances. So we're going to be placing hydrochloric acid, acetic acid, sodium chloride, and distilled water. And when we place those different substances in there, we're going to be measuring the pH, because the whole point of this experiment is to see how fast they move through the dialysis tubing. Okay? So when you do this experiment, you have to measure the starting pH. The starting pH. So you would be measuring the pH of the distilled water before you do anything and recording that. Then let's say we're going to be doing the HCl. So we put some HCl into this tubing. We would measure the pH of the HCl before you immerse it into the beaker. So you've got the starting pH of water, the starting pH of the HCl, and you record those down. Then what you do is you place it into your water now. As soon as you do that, you have to start timing. Because what's going to happen is some of this acid is going to move from the dialysis tubing through the membrane into the water. That's going to change the pH of the water. Okay? But the water is also going to move, and we'll draw this on the board for you, the water is also going to move into there. So if the acid is getting more water in it, it's getting diluted, and therefore its pH is going to change as well. So you leave it in there for 2 minutes, let's say. Then you measure the pH again. So you take the tube out, you measure the pH inside the dialysis tubing, and so now you have 2 pH values for that, one to begin with and then one after 2 minutes. And you should see that there's a difference. And you've recorded it for 2 minutes, so therefore you can work out the rate of change. In other words, how fast, right? So then we can do the same for our distilled water. How fast did the distilled water change pH? Okay? And then of course you have to rinse your dialysis tubing and then do the same procedure for each of the other substances. So you should have a table of values of the starting pH of all of these, and then the pH after 2 minutes for each one of them. So you can see which one causes the greatest change in pH, or the fastest change in pH, I should say. So hopefully that'll make sense. But I need to tell you one more thing that's very, very important. Okay, now this is, as I just said, very important. We want to make sure about lack of contamination. So when we use solutions here, we've got to be very careful that we don't just dip it into our beaker here, and then we've got to remember that there is now solution on there. So what we need to do is we need to rinse that with distilled water before we put it in there. So you should have a bottle of distilled water with you, something like that, and you give it a rinse. And now that is nice and clean, and then you can test the next solution. So if I put it in the acid, I put it in there, get a value, give it another rinse, put it into the next one, give another rinse, etc. And of course, you always rinse it before you put it back into here. So I've already rinsed this probe. So you pop it back in there, screw it on, nice and careful, and we're all done. So remember here, we're talking about the change in pH values. And so what you should have after collecting all your data is a table that will have the initial pH of all of these solutions. You'll then have the pH of the final pH. So let's just show you roughly what you're going to be doing. If you have the pH of the acid, so we have the initial pH, so let me just write it like that, little I means initial, and I might find that the pH of the acid started off with, let's say, 2. And then after 2 minutes, the final pH, right, subscript F, is 4, let's say. So to work out the change in pH, the delta is a Greek symbol that means change in mathematics and in physics, right? So change in pH is we do 4 take away 2, and how long do we measure it for? We measure it for 2 minutes. So 4 take away 2 is 2. So that means we have 1 pH unit change per minute. So that's the rate of change of pH for HCl. And you have to do the same thing for all of your others, because that's what you're comparing. How fast it's doing, the change in pH. And then of course you have to graph that and talk about why the values that you got occurred and think about experimental errors, etc. So hopefully that makes sense for you. Make sure that you clean up after yourselves, that you try not to contaminate, because other groups are going to be doing this, and we make sure that the solutions are the way that you found them. Okay, nice and pristine. Hope you have fun, and I'll see you in another